Hello, everyone. Happy Monday. I'm Adam. You might know me as Adam Tilted. I was just having a second cup of coffee and I thought I'd share it with you. So I've been thinking about something and I've been wanting to talk about it. So I thought today would be a good day. By the way, did you know that R2-D2 is the only character to be in every Star Wars movie? He's the only one. Hi, Danica. Did you know that R2-D2 was the only character to be in every Star Wars movie so far? I know. Crazy. So, this morning, science, yes. I want to talk about what science is and why I love it so much. And I want you to, just for a minute, I want you to forget what you know about science. Because I was, not C3PO. C3PO was not, well, I guess he was in the first one. Sorta. He was being built. Maybe you're right. I could be wrong. Maybe you're right, Danica, once again. If you know for sure, if you know if C3PO was in the first episode, let me know. I'm not going to watch that one because I hate those episodes. You posted a science video. Great. I'm going to go look it up. Oh, I got to practice doing this. That's awesome. This is a new feature in Ecamm, the ability to pop up Facebook comments. So I like that. That's cool. Science. I love science because it's a process. It's not a belief system. It's not a moral code. It's a process. It's a step-by-step way of doing things so that we can discover the things that we can predict. Now let me say that again so that we can understand that a little better. For example, I can predict that when water reaches a certain temperature, it will begin to boil. Well, why can I predict that? Because it's been established through multiple testing that water, so far as we know, always boils at this temperature. And it always freezes at this temperature. So that was determined through the scientific process. So you don't believe in science any more than you believe in the instructions for putting together something from IKEA. It's not something you believe in. It's just a step-by-step process to find out what we can predict. All right, so for example, let's say I had a question. Science usually starts with a question. I wonder if hot water boils faster than cold water. I wonder. So you got your question. Well, then I want to make a prediction and then see if I'm right. Okay? So I'm thinking that hot water will boil faster than cold water because I know that water boils at a certain temperature, and if the water is already hot, then it's closer to that temperature, so it makes sense to me. So I'm going to predict that hot water will boil faster than cold water. Well, now I need to test that to see if that's actually true. Seems simple, however, in real science, you have to isolate what you're trying to test. So I need to zoom in on what I want to know is time it takes to boil for this temperature water versus this temperature water. And any other difference that's out there, such as how much water, because if I like boil this much hot water and this much cold water, that's not a fair test, right? So so I make sure I have the same size pots. I have the same amount of water. I use the same source of heat that is the same temperature. I use the same thermometer, or one that is calibrated exactly the same so that I know they read the same temperature. And then I do my test, right? I see which one boils faster. Well, then I want to do it again because that might have just been a fluke. So I would repeat that. I would collect this information. I would write down, okay, in test number 1, I did this much water in each one. This one started at this temperature. This one started at this temperature. And this is how long each one took to boil. And I would do that for different temperatures and different amounts of water because I want to see if it's the temperature that makes the difference in the difference in time. If there is a difference in time. At this point, I don't know. So I'm collecting that data. All right. So I had a question. Which one will boil faster? I made a prediction. I think the hot water one will. So now I'm running an experiment to collect data that will help me answer that question. All right. So after I've done all this, maybe I do it 5 times, maybe I do it 10 times, maybe I do it 100 times. I look at my data and I say, okay, well, it's not usually every single time because there are always anomalies, things that are just happen out of the blue that, I don't know, just there was some random thing that happened you weren't aware of. So that's why we do it more than once. So I look at my data and I say, okay, well, this I'm going to put this up here. Hold on. Yeah. This, whatever, now I don't actually know the answer to this question. Maybe we should do an experiment. But after I looked at the data, I would then draw a conclusion. So yeah, I think this is why people get frustrated with science. Well, first of all, the reason why I think a lot of people don't get science is because they think that science is a bunch of things to memorize, like history, which I don't think history is a bunch of things to memorize either, or like math. But unfortunately, that's the way it's taught because that's the way it's easiest to test, which is just sadness. That'll be for another day. But science is not taught correctly because how do you make them choose A, B, C, or D on a question like which boils faster, hot water or cold water, and how do you know? You can't do that. So science is a thought process. It's a process of eliminating variables and seeing if you're right or wrong with your predictions. Now, if it turns out that I'm right, and hot water boils faster than cold water, and I have done this over and over again, and I feel really confident that, you know what, I've done all these experiments, and there's just no other explanation. Then I would publish that, and I would say to the scientific community, I have discovered that hot water boils faster than cold water, or cold water boils faster than hot water, or it doesn't matter. Whatever my results are, I say, here's my results. Here are my experiments. Here's all of my data. So you can look over it. You can do your own experiments. Check me. See if I'm right. Try to prove me wrong. That's what I love about science. It's self-correcting. Because if I do a poor job, if I'm a sloppy scientist, and let's say that I didn't control for all those variables and I boiled one little thing of cold water and one huge thing of hot water, well, this one's obviously going to boil first because there's less water to boil. But I might then draw the conclusion that cold water boils faster. once I present that to the scientific community, the other scientists are going to be like, no, this is not good science. We reject this because I can do an experiment that proves your conclusion wrong, and here it is. So that's all science is an organized way of learning about what we can predict. Now, a real scientist will hardly ever say anything is definite. You notice I say, I didn't say that science helps us find what's true, because our understanding of science is continually evolving. We are learning more and more and more and more, and that's how it should be. So when things don't line up with what we already know or think we know about science, it doesn't mean that we are wrong about what we know. It just means that there are some other things that we don't know, and we need to figure out how that all works in. And so that's been happening over millennia. This process of science has been at work, and it's gotten more refined and more refined and more refined, so that now there's a huge scientific community that is just ready to scrutinize all of your scientific declarations to see if they can prove it right or wrong. So with that being said, science is a way of thinking about what we can find out about the universe. I want to challenge you not to ever say that you're not good at science, because maybe you just haven't been taught how to do that. And so I'm going to take a few of these, videos I do, and we'll do some science experiments and just teach you the thought process. And I'm not trying to be condescending when I say that. I'm not trying to teach you how to think. I know you can think. But scientific thought is a very specific set of steps that you take, and records that you keep, and measurements that you make, and all of that, so that you can prove you are right. Yeah, so much is about the teacher. And I have to say that I was a pretty good math teacher and science teacher. I love science experiments. I love to find out stuff about the world around me. And I also like to share science experiments that you can do at home with your kids, because getting kids interested in science early on is so important. Because what happens is kids are naturally curious. Oh, thank you, Danica. That's sweet. Kids are naturally curious, and we school that curiosity right out of them, unfortunately. It's a sad state, but I've seen it. I was a science and math teacher for over 10 years, and I was also in the administration of several schools, and it's just the system is not built. The system does not allow. Well, let's put it this way. System makes it very challenging to be a good teacher, because in order to learn, you need to have a relationship with this person that you're trying to teach. And this factory model, this what is that? Assembly line model. That's how schools are built. That's how they're designed. I'm being literal about that. They were designed after the factory model, because that was what schools were for, was to get kids ready to work in the factory. That's not life anymore, and I really wish that we could rework schools, but of course, something like that's a huge endeavor. But do your best to support your teachers, because I know so many of them are really trying their best, and they're just limited by what they can do. This is great. I love this. The difference between science and messing around is writing it down. I love it. That's a great quote. Thank you for sharing that, because that's absolutely true. Writing it down and seeing if you can Do it again and again and again and again. Okay, happy Monday. I hope that this is a great day to start off a great week. I've got, I haven't planned my other shows yet, Orbit at a Tilt and Dealing with Different, but I'm going to get that up soon. Orbit at a Tilt, we're going to be talking about the Hubble telescope, and I'm really excited because the Hubble took some amazing images. I'm sure you've seen them. So make sure that you go over to the Orbit at a Tilt page and give that a like and a follow so that you get notified when I go live. I love you too, Barbara. I love you too. And your cute little kids. Give them a hug for me if you can catch them. Okay, bye. See you later.